Hello guys. Today in this session we will study about Maxwell equation. First, before we will study Maxwell equation, we will study first about static electric field and magnetic field, dynamic electric field and magnetic field. First, the source of static electric field is a unit charge. Unit charge doesn't change. Because it is a static, and it is not change since time goes by. And the source of magnetic field is a current. If current exists, then that means there is the change of unit charge, and so that makes the current. The source of static magnetic field is a current. Then dynamic electric field and magnetic field is a similar like static electric field and magnetic field. But there's some difference about this is a static and this is a magnetic. We will talk more deeply about telling this Maxwell equation. First, I will introduce about this name of the vectors. First, vector D, electric flux density. Vector E, electric field intensity. Vector B, magnetic flux density. Vector H, magnetic field intensity. First, we will study about this equation 1. This means divergence, and this means del. That means a difference here about the vector, and I will tell you about this equation more understandably. If the charge exists in the space, then the electric field, electric flux density will divergence. It is the name of Gauss law for electric field, and I will tell you about more deeply. Vector D names electric flux density, but what does the flux mean? That if there is a unit charge in here and there is an electric force about this unit charge and other object, and there is a line about electric force, that means flux. So as I talked before, if there is a charge in the space, then electric field, vector D, divergence in this space. Did you understand? Then next I will tell you about how to calculate this equation. First, this equation isn't it? Are you agree about this? The connection about this equation and this equation? Integral are for all kinds of vector D and divergence. It means the unit charge, total unit charge. Then we are so difficult to calculate about the 3 dimension. So we will do downgrade dimension about for 2 dimension. We can calculate this expression to this expression about 3 dimension and 2 dimensions in surface. We can easily calculate about this equation about this equation. Then let me talk about this number 2 equation. Magnetic flux density. But equation 1 and equation 2 has a difference. The output is this is a rho and this is a 0. Why people think the vector B divergence is an output about 0? It means not 0. First, there was some charge. Example, I will set the charge 2, and then the opposite charge make this output to 0. Because this vector B is a magnetic flux density, so we can say about there's an S pole and N pole. If N pole to S pole, there's a 2 connection about this picture, and it must have to go. If it means if there is a go out for 2 and it must come in 2, that means this expression to 0. Then I will talk about number 3 and number 4 equation. If first number 2 and number 1 and 2 equation is related about static electric field and magnetic field, and the 3 and 4 equation is related about dynamic electric field and magnetic field. Then let's go. If the magnetic flux density changes as the time goes by, then the electric field intensity will change. In how? It means current. It is a difference about this divergence. It means electric field density will spin into the speaker direction. I will tell you more clearly. If the vector B magnetic flux density changes about while time goes by, then electric field will spin and go to the speaker direction. You know what I mean? Then number 4. If there is an current, and if the electric flux density changes, it means the or. If the current exists and electric flux density changes into the time, then magnetic field intensity spins and like curve about the speaker direction. Thank you.